Hello everybody and welcome to Biology 1 2013, and today we're going to be talking about the carboxyl group. So the carboxyl group is actually really important, and here's what it looks like. You've got a C connected double bond to an O and then a single bond to an O minus, and this can actually change. So a carboxyl group, no, bad. Okay, so a carboxyl group can actually lose its hydrogen. This hydrogen right here can come off. If there's something that wants to attract to that hydrogen, it can pull it off. For example, an oxygen with a negative charge can come in, and that positively charged hydrogen will just pop off. And it's kind of because you always have to remember this and write this down. Oxygens are always going to steal electrons or try to steal electrons from carbons and hydrogens. When in doubt, the reason is oxygen is more electronegative, so it's going to pull the hydrogen or the electrons away. So anytime you see an oxygen next to anything like a carbon or a hydrogen, the oxygen is going to be negatively charged and the hydrogen right next to it is going to be slightly positively charged. In this case, because this is a double bond, this oxygen can actually pull electrons all the way from this O through that bond, and this, like I said, pops off. There you go. So let's take a look at what that looks like for real. So let's see. Alright. So here we have alanine, which is an amino acid. Now, we've talked about amino acids a little bit in the past, but not a whole lot. And you can see right here is the carboxyl group. You can see the carbon here, the carbon here, the O and the H, and then the other oxygen over here. So let's take a look at the structure again. We got go. Alright, so we got this hydrogen over here, OH, carbon, and then oxygen. Let's look at that again. OH, carbon, oxygen. Alright, so that's a carboxyl group. Now, I'm telling you that in water, that hydrogen is going to pop off. Alright, so let's look and see what that looks like. Okay, and that's what that looks like. You can see again we got the carbon double bond oxygen, but this oxygen is now without a hydrogen. And so let's see what that looks like when we add some water. Box builder, insert water 10, insert, and simulation, start. Okay. Alright, so you can see right away that the carboxyl group, the O's are attracted to those hydrogens. See that right there? And you can see this amine group is also attracted to the water. But this methyl group, this carbon group over here, seems to be sticking away from it. So this is charged now. So this is an O minus now. Go PowerPoint. Alright, so that's an O minus now. And that's basically the carboxyl group. Now a little bit of review. So we've talked about the methyl group and we've said it does something to DNA. But it's also going to add a property to anything you add it to, and in that if you add it to something that has charges or you add a bunch of them, they're going to be not attracted to water. So in very simple terms, when you have many methyl groups or many carbon and hydrogen areas, they're not going to be attracted to water. The OH is actually really important, and it's probably why evolution the way we know it happens. Basically, that OH group, the hydroxyl group, is where a reaction is going to take place. So if you see an OH group, it's a good bet that something is going to come in and bond to that oxygen right there. It's probably going to pop off a hydrogen and bond to that oxygen. And that's actually, like I said, how DNA is stabilized. What you do is you remove one hydroxyl group, and that means you have one less reaction center, and that turns out to be really, really important. And then DNA doesn't react with things, and it becomes much more stable. And you have you and I and this video and the wonderful time that we've spent together.